Hi, I'm Kathy Joseph, otherwise known as Kathy Loves Physics, and welcome to my second podcast of A Bit of Historical Context, where I give a bit of historical and scientific context to an issue that is interesting to one of my guests, and hopefully interesting to one of my guests. Today, I have my lovely guest, Alexis Dahl. Did I say your last name correctly?
You did. You nailed it.
Okay. Woo! That's the only name I will get correct today.
There you go.
Excellent. Would you like to introduce yourself, Alexis?
Yeah, sure. Yeah. Hi, I'm Alexis Dahl. I am a science communicator and video producer, and I make videos about geology and other kinds of science and history. And most of those stories center around the place I live, which is the Upper Peninsula of Michigan, which is this like gorgeous, relatively little known place with some of the coolest geology in the world.
Yeah.
Yeah, I feel like I should say if you're interested in that, my YouTube channel is just my name, so I'm pretty easy to track down.
Wonderful. And we will have a link down below, I think, unless I mess up the technology, in which case we will have a link later on, once again, to her website. And I've watched some of the videos and I really enjoyed them.
Oh, thank you.
So I thought you might be interested in learning a little bit about the history of how we figured out the age of the Earth and how it's connected to geology in sort of unusual ways.
Cool.
And it's mostly going to be about a guy named Ernest Rutherford. Sorry, blah, blah, blah. Have you heard of him before?
I'm somewhat familiar with Rutherford, but I feel like you say that name and my brain is like my 10th grade chemistry class.
Yeah.
It's like, that's what I can produce.
Something to do with the nucleus. He discovered the nucleus.
Okay,
So,
that's why.
And many, many other things. But I'm not going to start with him. I want to start with about 40 years before he was born. Okay. And a geologist named Charles Lyell, Lyell. I'm even cheating and looking down. Because the year is 1830, and Lyell published this very influential book on geology. And the reason it was influential is all had to do with time.
Okay.
Lyell said, look, I think geological processes happen in the past at the same rate they happen now.
Okay.
And that most geological processes happen slowly. There's very few catastrophic events, and they're not the main reason you have a mountain or you have a valley or you have these things here.
Okay.
And this was very different than the sort of catastrophism is what it was called. Okay. Basing everything on the flood and Noah's Ark.
Okay.
And one of the big things it meant was that you need the Earth to be really old. Because the processes are going slowly, and mostly it's from the slow processes. You need a really old Earth. And he basically just said, I mean, when people asked him how old the Earth was, he's like, however old it needs to be.
Fair enough.
It's like, that isn't my job, but I'm just saying, like, if it takes this long, then it takes this long. People are like, 10 million? He's like, sure, 10 million. They're like, 100 million? He's like, sure, 100 million. 10 billion? Like, sure. He didn't bother him at all.
Okay.
And it did bother physicists who are like, no, you can't just say it lasts as long as it will. But it influenced, so he directly influenced the guy who I guarantee you've heard of, but I guarantee you didn't know was a geologist.
Oh, interesting.
I'm not trying to trick you. Yeah. I'm just trying to say you were going to be surprised.
Cool.
Do you have any guess who was a geologist who is a scientist in the 1800s who I guarantee you heard of?
I don't. I feel like I would just be taking a random guess, so tell me more.
Okay. Well, let me tell you whose name was.
Okay.
Charles Darwin.
Oh, you're right. See, I would not have guessed that.
Right. Charles Darwin, the year after Lyell published, got a job to go on a boat called the Beagle.
Okay, yep.
To do both geological studies and studies of fauna and flora and what have you.
Why do I only know about the biology side of the story?
Well, because first he published his journal into research. I wrote it down. In 1845, he published the Journal of Researches into Geology and Natural History.
Okay.
But this study created this idea. His travels and his thoughts about natural history made him come up with the idea of on the origin of species. In
Ah, that
other
makes
words, he
sense.
came up with evolution because of his trip studying geology and natural phenomenon in the
Cool.
1830s. And he publishes in 1859. And this also needed a long old Earth.
Yep.
And so once again, that inspired the geology, and especially Darwin's theory, made some scientists go, okay, we really need to figure out how old the Earth is, so we
Right.
can disprove them.
Oh. Why were they coming from a lens of like, we need to disprove this versus just we need to learn more?
Because they thought it was anti-religious.
Ah, okay. By anti-Christian specifically, or
Anti-Christian
okay,
specifically.
cool.
Because, well, I mean, in arguments, you could say it was anti-Jewish or anti-Muslim,
Oh,
but there
sure.
weren't very many Jewish and Muslim scientists who were listened to in the
Mm,
1800s, especially coming up. This was specifically to England.
got it. Okay.
England was where Darwin was. England was where Lyell, he wasn't, I think he was Scottish, but I might be wrong, was from. But this was the area where everyone was debating this.
Gotcha.
And
Okay.
there was also another Englishman, oh gosh, and now his name is escaping my head. And he started a magazine called Nature.
Oh, like the
Like Nature,
nature?
yes.
Okay.
Norman Lockyer,
Okay.
who is delightful. I love Norman Lockyer. One of the things I loved about him is when he published informal papers, he would be the most informal person I've ever read. He would just be like, I was really surprised when I found this. So I called my wife in and had her double check. And she said I was right. And I was so surprised. 4 exclamation points. Never seen a published paper with multiple exclamation points before.
No, that's like the opposite of how I was taught to write papers.
Yes. He was the most informal, delightful person. I just loved him. And in fact, I made a video about him, and the he was an astronomer.
Okay.
Actually, he was a completely amateur astronomer.
Cool.
He was working for the government in England, and he was on a train, and his friend said, I bought a telescope, but I'm never using it. And he said, oh, I've always wanted to look at a telescope. So
Oh,
he starts looking at the telescope, joins astronomy clubs, and eventually discovers a layer of the sun, and discovers helium in the sun.
oh my
I
gosh.
mean, like, he becomes huge. His books are just like bestsellers and they're really well written, even though
Cool.
they have lots of exclamation points. Maybe that's why
Yeah.
it helps it, because his informality. And he didn't have a formal education in science at all. He was a linguist for the government.
Huh.
Then he asked his publisher if he could start a science magazine, because he was working for another one that fell apart.
Okay.
They said okay, and he was good friends with all of these people, including Darwin and this guy who they called Darwin's bulldog, who
Oh boy.
kept pushing Darwin's theories. So everyone published in Nature to
Oh.
fight. All these arguments were sort of debated in Nature magazine
Okay. Yeah.
because he was promoting it. So one of the people who didn't like Darwin's evolution and didn't like geology taking too long was a physicist named Sir William Thomson.
Okay.
And Sir William Thomson was later ennobled, sorry, not knighted. Knighted is when you get the Sir,
Hmm.
ennobled is when you get nobility, to be called Lord Kelvin.
Ah, okay.
Temperature.
Yeah. Do you know where the Kelvin thing came from?
Yes.
Okay.
So William Thomson, aka Lord Kelvin,
Hmm.
he wrote a paper in I'm not 100% sure of the year. I'm thinking it's 1849, where he read this other thing about this French scientist named Carnot,
Okay.
who had these theories of heat, and he used those theories to say there is an absolute minimum temperature.
Hmm.
And Thomson wasn't the first person to say this,
Hmm.
but he was the first person to say it was negative 273 degrees below zero.
Okay.
Way back then.
Yeah.
So that's why they named the Kelvin scale after him.
Hmm.
But it's very confusing because all of his work for most of his life is known under the name William Thomson, which is an
Yeah.
unfortunately common name in England.
Mm.
Lots of Thomsons coming up.
Yeah.
And so it does make it confusing. But yeah, that's why he's named after Kelvin. And he was a big person in the history of thermodynamics, the history of heat flow.
Okay. Makes sense.
But when he decided to figure out how old the Earth was, he used heat flow.
Ah.
He said, okay, let's say the Earth started as a giant ball of fire,
Okay.
and then it's cooling down.
Which is not a bad assumption.
Not a bad assumption at all. He was an excellent scientist.
Cool. Yeah.
Made some mistakes, but an excellent scientist, and everyone does. And with this method, he predicted that the Earth was between 10 and 20 million years old. Oh, wait,
Okay.
20 and 40 million years old. And so he's like, okay, geologists, okay, Darwin, you're all wrong.
I have spoken.
I have spoken, the Earth is not old enough. And when he did this first was in 1862, but he was an incredibly popular and prominent scientist. Like I said, he was given ennobled and stuff like that in 1892. So he was still a big deal.
Mm-hmm.
And so that was the big conflict. Physicists said the Earth is really young, or relatively really young.
Mm-hmm.
Biologists or evolutionary biologists and geologists said, the Earth is as old as we need it to be.
Sure.
And there was nobody saying, hey, there's a physics reason to say the Earth is not as old as it needs to be. The Earth is old enough that your ideas could be valid.
Okay, gotcha.
And that brings us to Ernest Rutherford.
Okay. Also, that was a really lovely introduction. I feel very caught up now.
Oh, good. Oh, good. Okay, great. I'm glad you do.
Oh, yeah.
Especially because I was forgetting Norman Lockyer's name, and I feel bad because he's one of my favorites. Some people study history and they're sort of a bit dispassionate about the people they're talking about.
Yeah.
I have my favorites. I have my people that I'm disappointed in. I have my people I hate.
Yeah. I mean, people are people. People are complicated. They're not,
Yes.
objects.
Yes. I just feel like once I read their words, especially their letters, and find out their stories, I feel like I know them.
Oh, sure.
Sort of know them in an internet way. Like you have a friend that you know on the internet. I don't know everything about them.
Yeah. Yeah, that's cool. I know you as you're presenting yourself in this way.
Right. Well, and sort of their idiosyncrasies come out.
Mm-hmm.
That's the stuff I love, especially Ernest Rutherford. He was quite idiosyncratic. Okay, so with him, I would like to start in 1894 when Ernest Rutherford was 23 years old and was a science teacher in New Zealand, where he was from.
Okay.
And he asked his girlfriend, Mary Newton, to marry him.
Okay.
And this is the most important event of his life, the most important event towards the development of science. This is the pivotal moment.
Interesting. Okay.
She said no. She said it would be idiotic.
Oh, no.
No, it's not oh no, actually.
Oh, okay.
Don't worry. Because the reason she said it would be idiotic is not because she didn't love him.
Okay.
But because she did love him. She said, it would be idiotic to marry you because if I marry you, you will stay a bad high school teacher here forever. You
Okay.
are too smart to do that. And too bad a teacher. She didn't add that, but
Oh.
according to his students, he was quite bad.
Oh.
And you need to do something with your life. I will wait. You do
Interesting.
it. I'll wait for you.
Okay.
And so he did. And then it turns out she was prophetic,
Hmm.
because the very next year
Okay.
there was a scholarship from England. So years before, Queen Victoria had this big jubilee,
Okay.
and they ended up making a lot more money than they spent,
Hmm.
which is startling, but they did.
Cool.
So they used the extra money for different things. As far as I understand, if you've ever been to England and been to the Prince Albert Museum,
I have not been. I should go though.
I hear it's awesome.
Yeah.
They made that because of the extra funds from that
Huh.
was my understanding.
Okay.
But also they made a scholarship so that people living in the English, who are under the English banner,
Hmm.
so to speak, in the English Commonwealth,
Okay.
if
Yep.
they were white and male, of course, could get a scholarship to travel and study science.
Okay.
And every other year, New Zealand and Australia alternated who got the scholarship.
Okay.
So the next year, it was New Zealand's turn, and Rutherford was one of two people who applied for the scholarship,
Whoa.
and he lost.
Oh no.
The
There's
other
so
guy
many
won.
twists.
But this is why Mary's rejection of the marriage was so important,
Okay.
because turned out that the guy got engaged to a woman who wasn't worried about her boyfriend not fulfilling his
Sure.
destiny,
Yeah.
and that invalidated the contract. He was
Oh.
only allowed to go as a single man, not as a married man.
Okay.
So it went to Rutherford.
Huh.
Supposedly, Rutherford was digging potatoes at the time. And he threw down the thing and said, "That is the last potato I will ever dig."
That's iconic. I love it.
Isn't it great? Yeah, he was from this huge family of, his dad was Scottish and his mom was English.
Okay.
And they moved to New Zealand to, as he put it, raise a little flax and a lot of children.
Oh boy.
I think he was one of 14 children. I should have looked that up again. I
Oh.
mean, just this huge family. And
Yeah.
mom was just like, education, education, education.
Cool.
And yeah, and he was like, we were too poor, so we had to think. Was his,
Mm.
and so he kept on getting scholarships. But then once he was done with school, the only thing he could think of was being a teacher. And like
Okay.
I said, he struggled a little bit, not because he wasn't nice, just with discipline. Like
Okay. Yeah.
the students would go crazy and then sneak out, and then someone else would distract him with some science question while everyone filed back in, and he would never notice. Or if he
What?
disciplined them, they would just start asking him about stuff, and he would just start going off, and then they,
Oh
and then he
man.
had to, hit them with a switch as you would do at the time.
Oh.
And they just said it was madness. It kind of reminds me of when I was a high school teacher.
Oh man.
Except no hitting with switches, but definitely easily distracted. Um,
Yeah.
sorry, all my students. I taught high school for many years,
Okay.
and discipline was not my forte.
It's hard. I am not a teacher, but I'm just trying to put myself in your shoes. And I'm like, that would be so difficult.
It's sometimes delightful, but the whole discipline thing is not delightful. And
Yeah.
apparently Rutherford didn't like it either.
Well,
So
there you go.
anyway, he gets a scholarship and he decides to go to England because there's a guy in England named J.J. Thomson, another
Okay.
Thomson,
Oh yeah.
who's the head of Cavendish Labs.
Okay.
And as the new head of Cavendish Lab, J.J. Thomson decides to change all the rules and let foreigners come be grad students,
Okay.
which before that you had to go to Cambridge to go there.
Oh, interesting.
So Rutherford is one of the first group in the group of first people to get there. He gets there, he says, J.J. Thomson is not the least bit fossilized, but the other students treat him badly.
Oh,
And
interesting.
the Irish student badly.
Hmm.
Because, you aren't proper English,
Okay.
This is,
Yeah.
gosh, I'm looking at the years. July 1895 is when the chemist doesn't get the scholarship. So this is late 1895 by the time he gets to England. And he says, he writes Mary, is like, these people, I'm about to do a Maori war chant on their face. They don't act better.
That's very specific.
I love it. I love this image of these uptight people being prejudiced against him for being from New Zealand.
Yeah.
And loses it and goes, have you ever seen those Maori? Blah, blah,
I have, yeah.
Your eyes bug out. I just imagine they would freak out. But
it might be good for them.
I think it would have been good for them. But what happened instead is a week later, he gave a talk and he wrote his girlfriend again. He's like, after I gave that talk, everyone's trying to be nice to me now.
Oh, ho, ho. How the tables turn.
Right. They realized. Now, right when he arrived, right afterwards, the X-ray was discovered.
Okay.
And everyone went crazy.
Okay.
Everyone took out, it's funny, that's what I was talking about X-rays last time.
Yeah.
Everyone took out their X-ray machines, start studying X-rays. J.J. Thomson tells Rutherford, stop studying radio waves, because that's what he was studying before. And try for a millisecond, not a millisecond, for a week or two, Rutherford actually had the world record for the longest radio signal.
Huh.
And then someone else. It was one of those things where one person got it.
Yeah.
And J.J. Thomson's like, no, there's nothing interesting in radio. What you should focus on is X-rays and studying the electrical effects of X-rays. X-rays can electrify the air. You should study that. So he starts studying that. Meanwhile, by the way, J.J. Thomson realizes that the tube that makes the X-rays was actually made of a beam of electrons. He discovers that they're microscopic subatomic particles that are charged.
Okay. Cool.
He doesn't call them electrons, but they're quickly called electrons.
Oh, neat.
At the same time.
Okay.
Partially because of the discovery of the X-ray.
Yeah.
Okay. So there's Rutherford studying X-rays and electrify. And then Rutherford reads about radioactivity coming out of France.
Okay.
So right after the X-ray is discovered, there's a guy in France named Henri Becquerel.
Okay.
And Henri liked to study fluorescence and phosphorescence.
Cool.
When you shine light on it, it glows.
Yeah. Cool stuff.
Yeah, cool stuff. And he was like, wow, if X-rays can make fluorescent objects, if cathode rays, i.e. a beam of electrons, can make fluorescence glow, and cathode rays can make X-rays, maybe fluorescent materials can make X-rays.
Interesting. Okay, yeah.
So he happened to pick up fluorescent uranium. And I take a moment to pause. How many materials are fluorescent or phosphorescent?
Yeah,
right?
Yeah, right. It's a big collection.
Randomly picked uranium.
Huh.
It's every once in a while, it's worth, I think, to take a moment and pause and think about how discoveries are so hinged on these weird little coincidences.
Yeah.
It's unbelievable, right?
Yeah. Was it purely random with uranium? Was there a lot of uranium? Okay. I didn't know if there's a lot floating around at that time.
Father was a scientist who studied fluorescence and phosphorescence, and he also studied phosphorescence and fluorescence. So it's possible. I'm not sure. I don't study phosphorescence. But I know there's plenty of them. There's plenty of them. So I think as far as I could tell, he didn't publish. when he published, he didn't say, I was thinking of this.
Mm.
He just said, I thought if X-rays make fluorescence glow and, cathode rays make fluorescence glow and cathode rays make X-rays, maybe fluorescence will make X-rays. So he takes this uranium, puts it in the sunlight on a film that's wrapped in paper, and yes, it develops it.
Cool.
This is great, publishes it. Then, like 3 days later, he makes some uranium. It turns out that the uranium, he had to make it in a chemical process to make it fluorescent.
Okay.
It only lasted a little while.
Hmm.
And it wasn't sunny.
Okay.
And the next day wasn't sunny. And the next day wasn't sunny. It's like, oh, great. Now it's not as fine. I'll just develop the film as a baseline to compare it.
Oh, sure. Yeah.
Guess what happened? Just as bright. Uranium made these rays, developed things without any sunlight to absorb, without glowing at all.
Interesting. Okay.
Uranium itself, they first started calling it uranium rays. He discovered that uranium emits something that can go through paper, develop film, something. And he also found that uranium, like X-rays, can electrify the air a little bit. Now, this was, I'm looking up the date, that was May of 1896.
Okay.
The very next year, Marie Sklodowska-Curie gave birth to her daughter.
Okay.
And her husband said, look, you helped me get my PhD. It's your turn.
Okay.
You have to do something to get your PhD.
Yeah.
My dad will help take care of our kid. And he did.
Cool.
Yeah, I know. And you need to study something. And she was reading the papers and she read about the uranium rays.
Mm-hmm.
And she knew that her husband and his brother had discovered something called piezoelectricity.
Okay.
Pressure can create electricity for certain materials, and electricity can create pressure for certain materials. And so her husband, Pierre Curie, had built a very, very sensitive electric meter using this effect.
Okay.
The world's most sensitive electric meter. So she's like, oh, what I'll do is study the uranium with my husband's electrically instead of having it develop film.
Neat. Yeah.
So there's a way of saying how radioactive something is.
Okay.
Do you see what I mean? If it develops films, it's just a yes, no.
Right.
If it's this machine, you know how radioactive something is.
Yeah, totally. And I mean, especially if you're going to do further research, knowing what kind of scale and quantities you're dealing with is going to be huge.
You have to have a scale, right? So she puts it on this thing. She first studies uranium. She says it's not chemical. Doesn't matter what temperature it is. Doesn't matter what you mix with. It's just how much uranium it has is how many uranium rays it makes. Okay. So she starts studying every material she can find.
Cool.
And she discovers that thorium also makes these rays.
Okay.
And but unfortunately, right as she's publishing, someone else finds that thorium also makes these rays. But she publishes it because she says this way will tell you how radioactive it is. An expression that she made up.
Cool. Okay.
We call it radioactive because she liked that term.
Huh. Neat. I did not realize that.
Yes.
Oh, cool.
So that is the paper that Rutherford read.
Okay.
And and then mind you, while she's doing this, I should probably add up, she's playing with this and she starts taking every item she can and seeing if it's radioactive. She can't find anything else.
Okay.
But then she's studying uranium ore, which is a mix of uranium and other things.
Okay.
And it's more radioactive than pure uranium.
Oh.
And she's like, there's something hidden in there.
Yeah.
We've never seen before.
Okay.
So her husband quits what he's doing to act as her assistant. And they just start doing every chemical process they can possibly think of to this uranium ore to see if it's more radioactive and to isolate what they've got. And the first thing they do is they discover polonium, which is named after her home country of Poland.
Oh, cool.
Yeah. And then the next one they find is there's another thing hidden in that same uranium ore, which they call radium.
Ah, okay. I just finished reading the Radium Girls, so I was wondering when that was going to come up.
I couldn't make it past page like 2.
Yeah.
It was too brutal. I'm like, it's like, and then her jaw, I'm like, yep.
Yeah,
I'm
it's
done.
it's I was gonna describe it as like a very dark book, which it is, but it's also just deeply disturbing because it's nonfiction.
Mm-hmm. Mm-hmm. I'm told there's a YA version of the book,
Oh.
which might be a little bit easier for me to deal with without getting so sad.
Yeah.
I still think I'd get sad. I'm too sensitive.
Yeah,
And
it's all that to say.
yeah, she didn't know that it was dangerous. In fact, she talked about how beautiful it was to work among the fairy glow
Oh,
of
sure.
glowing radium in their lab,
Yeah.
and would like carry one piece in her pocket
Mm,
all the time. Yeah, it makes me very anxious just listening to reading about it,
yeah.
I just didn't know. But
Right.
anyway, Rutherford hears about it.
Okay,
It's
cool.
like, that's fascinating. I want to study these, which were now called Becquerel rays.
Ah, okay.
For Becquerel, who discovered the uranium. I
Mhm,
want to study these Becquerel rays the same way I've been studying the X-ray. They're similar.
mhm.
I'm going to put it on a similar scale, but I'm not going to do anything chemical because I'm not a chemist.
Okay.
I'm going to do something physics. I'm going to put this on a scale where I can measure how much electricity it makes and then block it with thin pieces of gold and
Oh,
seeing how it affects the strength, how powerful these rays are.
okay, sure.
So he starts putting these things, and as he puts layers of gold, the amount of electricity he gets goes down, down, down. And then after a while, it stops going down.
Okay.
And he's like, oh my gosh, there are at least two kinds of radiation.
Mm,
One that can make it through thin pieces of gold and aluminum,
okay.
and one that can't.
Okay, I see. I follow.
And he called the one that was easy to block for the Greek letter for A, alpha,
Oh.
and the one that was harder to block for the Greek letter for B, beta.
Oh, cool. Okay. I'm like, I've heard of that. Neat.
Yes, yes. That's where alpha radiation and beta radiation came from. And a little later, it was discovered there's a third kind. It's called gamma radiation.
Okay.
It took a little while to figure that one out. And
Yeah.
so it ended up, and Rutherford ended up naming gamma as well. He wrote
Okay.
a paper later on that said, there's alpha, there's beta, and there's gamma. And everyone's like, okay, you're probably right. Let's use your
Neat.
language. But
Seems
anyway,
fair enough.
yeah. So he publishes this, and he ends up actually writing letters to Curies. They become sort of pen pals, friends,
Oh,
friendly.
yeah.
Um, and he finishes his grad school, and he's like writing to his girlfriend still,
Mhm.
who's still waiting to get married.
Oh, what a gem.
That yes, they were both delightful. That he's trying to get a professorship, but he doesn't think he can get one in England
Hmm.
because no one wants to hire him because he's from New Zealand.
Okay.
But then a person from Canada writes to his boss and says, we have an opening. And his boss says, well, I've never had anyone better than Ernest Rutherford. You should hire
Oh,
him.
cool.
So off he goes to Canada.
Okay.
So he's a professor in Canada. And almost immediately when he gets there, he's approached by an undergraduate named Bobby Owens. And
Okay.
Bobby says, I'm supposed to do a science project. What should I do? And Rutherford says, you know what you should do? You should do the same experiment I did with uranium, but do it with thorium.
Okay.
Just repeat it.
Yeah, sure.
Put the stuff there, put the little sheets, see that there's alpha and beta from
Mhm.
other radioactive materials.
Yeah, perfect.
So guy goes back, comes back to him, and he says, there's something weird going on. There's something really weird. I just put the thorium there,
Mhm.
and the results, even without a sheet, are all over the place. And if I
Oh,
open and close a door, like I change the numbers,
huh.
which makes no sense, right?
Yeah, like,
So
excuse me.
Rutherford,
I was gonna say, like, "Excuse me, Rutherford, this was supposed to be a straightforward project.
right.
What is happening?"
This is supposed to be easy and it's not working.
Hmm.
And Rutherford's like, goes in there and figures out, yeah, it's not working.
Okay.
What's happening is that it must be producing a radioactive gas,
Oh,
maybe little powder that you can't see.
okay.
the instinct was it must be producing something that can
Mhm.
move with the air.
Okay, makes sense, yeah.
And so what he does is, so they publish this, and then they also do something which I thought was brilliant. They take a little bit of thorium oxide, they put it at the end of a long tube,
Okay,
where on the other end is a chamber with the electric meter.
okay.
Then they use filtered air to blow the air
Oh.
over the thorium so that the gas that they're making goes into the chamber.
Oh, that's so smart.
Isn't it? And then
Yeah,
they turn off the air
okay,
and measure the radioactive gas.
cool.
And what they found was really shocking because it would make electricity,
Mhm.
and the electricity would half in about a minute.
Oh.
What level it's at, it would
Mhm.
always half its value about every minute.
Okay.
And they discovered in this way that radioactivity has a half life.
Yeah, interesting. Also, like, what a weird discovery that must have been.
Exactly. I mean, one of the joys of this job is that I get to answer questions I didn't know I had.
Okay, yeah,
That makes sense. Like,
totally.
how do we know electricity flows? What do we do with a battery before we had battery operated things?
Yeah, uh-huh.
Like, what do you do with the first battery? What did you, and this one, like, how did they know that radioactivity worked in this way?
Mhm.
And that's how they knew it, because this particular gas happened to have a half-life of like a minute.
Yeah,
They could clearly see it dropping by a half every time, irrespective of how much material there was.
yeah, and it was thorium, right?
Yeah,
Yeah.
thorium, I think.
Also just really convenient they were working with that one, because 'cause I'm just thinking, like, some elements have a half-life that's, a four-digit number of years. You'd never notice.
You never ever know, and because it was the gas,
Yeah, right.
not I mean, I think the gas helped them understand this.
Sure, sure.
So they published this. He actually gets in a bit of argument with the Curies about this, but
Okay.
eventually they agree he's right. Um, and so at the time, Rutherford also gets, oh, finally, I forgot to mention, when he gets to Canada, he finally gets to marry his girlfriend.
Oh, yay! Oh, good for them. I'm so glad that worked out.
Me too. They had a very lovely, I think I wrote it down. He wrote her that he was going to have a swell lab to knock the shine out of the Yankees. But rejoice with me, my dear girl, for matrimony is looming in the distance.
Oh, also, like, what a lovely letter that must have been to get. Like, "Oh, finally."
Right. Well, I'm startled when I read these things because we have these images of scientists being sort of dour, only
Yeah,
interested in science,
right.
and of one personality type.
Right,
And
yeah.
I see such ranges in personalities and styles.
Oh,
And
yeah.
Rutherford was a big, loud, pushy, and also deeply kind and
Huh,
less person,
yeah.
unless you destroyed his equipment, which they
Oh.
said he had a unfortunately long memory.
Oh, no.
He was very mad when people destroyed equipment, and he didn't like theoreticians. But other than that, he was delightful, and he was also unusually delightful towards female students.
Cool.
When he got to Canada, he actually hired a woman named Harriet Brooks to
Okay.
be his graduate student. And she starts studying these thorium gas and discovers that she thinks its mass is different than the thorium.
Ooh, okay, okay.
One of the things she discovers. But she is not a chemist, she is a physicist. She
Mhm.
also discovers that the thorium gas, I think it's called radon, and the thorium are do emit alpha rays and alpha
Okay.
beta and alpha particles and beta particles and gamma rays as well. So everything radioactive makes these three things.
Okay, okay.
So then so now we are at, so 1899, he goes to McGill University in Canada.
Okay.
that's the year. I mean, like, it's amazing. If you look up Rutherford's publications for like 1899, 1900, 1901, there's like 40 publications every year.
Oh
They're
my gosh.
crazy. It's astonishing how
Yeah.
prolific this guy was and how collaborative he was. He
Oh, okay.
always put the other person's name in there.
Okay.
Bobby Owens, the reason we know his name is because he published with this undergrad.
Okay. And
Most
was that like just not a common thing to do at
no,
the time? Okay.
and still today in physics. I mean, I was in grad school. If you helped your professor out with something, sometimes you get your name on it. And usually if you did get your name on it, they would say like, we're doing you a special favor by putting your name on it. Not like, hey, you helped out a tiny bit.
Yeah.
Name
Okay.
on it. I came up with all the ideas. Yeah. So, and also, like I said, he hired this woman when most universities wouldn't let women work there. And most people, I mean, I honestly cannot think of another physicist who published with a woman's name who wasn't married to or sleeping with the woman.
Okay.
It's kind of challenging.
Wow.
Is this possible? I mean, Marie Curie published with Henri Becquerel eventually,
Okay.
but it was only after. I mean, it's not the
Yeah.
same thing.
Right. Right.
But anyway, so so another thing, very important thing happened, which was in March of 1901. Rutherford went to a debate about the existence of electrons because chemists hated the idea and physicists loved it. We forget all these drama, but man, there's new ideas. There's resistance to the idea, and then there's people who love the idea, and the importance is it's not a bad thing that there's resistance to new ideas.
Okay, sure.
In my mind, it should be debated. It should be, and you have to convince people that your idea is good. So he was debating this, and he debated it with a chemist named Soddy.
Okay.
What was his first name? Frederick Soddy. And Soddy not only lost the debate, he decided to work with Rutherford from then on.
Oh, cool. I mean, what a good way to lose.
Right. So Soddy starts studying the radiation from these radioactive gas.
Okay.
Chemically, not physically. So
nice.
he starts trying to see if he can combine it with anything.
Mm-hmm.
And he's like, this is non-reactive. This is a noble gas.
Okay.
It didn't start off as a noble gas, but now, not only does it have a different mass, but it also reacts differently.
Okay.
It's transformed into something else.
Huh. Yeah.
And he says, I wrote it down. I remember quite well. This is Frederick Soddy, he says, wrote, I remember quite well standing there transfixed as though stunned by the colossal import of the thing and blurting out, Rutherford, the thorium is disintegrating and transmuting itself into an argon gas. Rutherford replied, for Mike's sake, Soddy, don't call it transmutation. They'll have our heads off as alchemists. Transformation.
Oh boy.
So they've been trying for, I mean, Newton spent most of his time trying to be an alchemist and transform things into gold. People have been trying for forever. Turns out radioactivity, things are transforming from one thing to another.
Wild.
And with this half-life, half-life is how long it takes to transform from one thing to the next thing. So that is actually why Rutherford won a Nobel Prize in chemistry, which he found very strange. He's like, well, I'm not a chemist, but I had a swell time.
Right. Like, thank you anyway. This medal is nice.
Exactly. The money is great.
Oh, yeah.
He was eventually knighted. And he told his daughter, he said, you may now call me Sir Ernest, young lady.
That's like a very dad thing to do.
he was definitely a dad thing. And by the way, the Harriet Brooks was not by far not the only woman who worked for him.
Okay.
There were like a dozen women who worked for him at one time or another, and another couple dozen who said, thank you for your support and your help and your, I just wanted to point it out because it's comforting to know that even people could be decent to women scientists as well as male scientists.
Yeah.
Yeah. So anyway, so he realizes that things are transforming from one thing to another. And he also has this theory that alpha particles are really helium well, he doesn't think they're nuclei because he hasn't discovered the nucleus yet.
Okay.
But he thinks they're charged helium particles.
Okay.
He wasn't able to prove it yet, but he had a theory that they were helium. So he says, okay, if we look at a rock and we see how much helium is in it, trapped in it, versus how much of the parent, how much of the radioactive material you have in there, you can determine using the half-life of uranium, because they figured this out by then, how old the rock is.
Okay, cool. Totally makes sense.
So he takes the rock, he figures out it's 40 million years old. He actually wanders around campus and he said to someone, hey, how old's the Earth? And the other person says, well, everyone knows the Earth is 20 million years old. Lord Kelvin told us. And he says, that's funny. This rock is 40 million years old. This rock is twice as old as the Earth.
I'm just imagining like Rutherford wandering around, just like pulling random students aside. Just, what do you think about this rock?
Exactly. In fact, he ended up giving a talk in England. And I wrote this one down. And he was worried beforehand because guess who was going to be in the audience?
Oh no.
Lord Kelvin.
Oh boy.
So he said that he started giving the talk. He was very nervous, but then Kelvin just fell right asleep.
Like literally?
Yeah, during the talk. He's like, this is great. I'll just give my talk. He'll sleep through the talk. No problem, right?
Huh. All right.
So, but then he said that I wrote it down because I wanted to get his language because Rutherford is delightful. So this is what he said. I saw the old bird sit up, open an eye, and cock a baleful glance at me. Then a sudden inspiration came, and I said, Lord Kelvin has limited the age of the Earth, providing no new source was discovered. That prophetic utterance refers to what we are now considering tonight, radium. Behold, the old boy beamed upon me.
Huh. Wow.
He's like, you said the Earth wasn't old, but provided there wasn't anything new, but radioactivity adds more heat.
Yeah.
So don't worry, you're like prophetic.
Right. Like you're fine. Just go ahead. Keep having your snooze. Like you're doing all right over there.
And so, but at the same time, so the helium thing wasn't the greatest idea. And they start to try to study how these things, what they decay into.
Oh, sure.
And it was super confusing because they didn't know about the nucleus, neutrons, or isotopes.
Oh, yeah, that would be very confusing.
Very, very confusing. And in fact, Rutherford ends up discovering the nucleus between 1908 and 1913.
Okay.
And then Soddy in 1913 creates the idea of isotopes.
Oh, perfect.
And then Rutherford creates the idea of neutrons in 1920.
Okay.
So
all coming together.
It's all coming together, but they're still trying to figure it took till 1956 before they discovered how to use radioactive decay to get what we consider even close to modern estimate of how the Earth is, which is about 4.5 billion years.
Right.
But that is how we know the minimum age of the Earth. Actually, and I forgot to add, part of it was that when a rock is molten, it's only when it cools down that you start to have the let me just skip that. Forget it.
All right.
Sorry about that comment. So anyway, that's how they figured out the age of the Earth, and that's how it's related to geology.
Wild. Also, well done.
Oh, thank you.
Yeah, I'm thinking about like Rutherford's amazement of like, oh my gosh, this rock is 40 million years old. That's so old. And then skip ahead a couple of decades. And it's like,
And
oh
then,
yeah, 4.5 billion.
right, right. No wonder you've easily found a 40-million-year-old rock.
Right. It's a
Young
baby.
rock. It's a baby. Yeah, he wasn't particularly looking for an old rock.
Sure.
Like wanted something with radioactivity in it and then figure out the age. Yeah. It's also amazing when you stop to think about how crude their equipment was.
Oh yeah.
I mean, it was basically, cigar boxes and tin cans. And no wonder he got so upset when someone messed something up with his
Sure.
equipment. It was very basic equipment, and they couldn't go to the store and get, I mean, even earlier, they had trouble because they couldn't buy insulated wire.
Oh man.
You kind of if you've ever seen pictures of Michael Faraday's experiments,
Hmm.
they kept his equipment and it looks like a mummy's device because it's wrapped in cloth
Oh, interesting.
because they did not have any advanced equipment to use.
Yeah. Can't
So,
just, go online and contact your local supplier and have them send
right,
a technician out.
right, exactly, exactly. So, which sometimes, strangely enough, ended up leading to new discoveries
Okay, sure.
because they had to build everything themselves.
Hmm.
Sometimes you discovered something new, like when they invented the battery. When Volta invented the battery, he sent the publication to England because he spoke many, many languages.
Hmm.
Volta was Italian,
Okay.
and the head of the secretary at the Royal Society and his friend read it before it was published. He's like, "Let's do it," but they didn't have like alligator clips.
Ah,
So
okay.
instead, they put their wires in salt water because salt water is
Oh,
conductive. And then it turned out the wires in salt water made one thing, both of the wires bubble. And one was bubbling hydrogen and one was bubbling oxygen.
oh, amazing.
So that's how they found chemical that batteries, voltages could create chemical decomposition.
Oh, cool.
And that led to a host of new elements being discovered. But
Oh,
also, if they'd had alligator clips, they might not discover.
right.
Right, exactly.
Oh,
So
fascinating.
that was my talk about the age of the Earth. If you are interested in like the combination of science and real science and history, you might want to check out my new book, The Lightning Tamers, which is coming out October 12th. And I'm going to have very, very exciting news, meaning that I think you will be able to read it before October 12th if you pre-order it. So there's a scan to join the Lightning Tamers waiting list. And I'm by soon, I mean, like I was discussing with my tech person how to set this up before we gave this talk. And we realized, okay, there's more technical difficulty. I'm good with history. And then you get me to the technology and I'm like, how do I quit? How do I oh no, oh no. So we've had technical difficulties, but if you join the waiting list, you should be able to purchase it and read it within the next 3 or 4 days, hopefully.
Cool. That's so soon.
That's so soon. Oh my gosh. And then I'm going to have the unboxing video, and then people are going to complain that I use my hands too much because I am so excited.
I mean, I'm glad you're excited. It's worth being excited about. A book is a big thing.
Right. Right. Actually, this is the first of 7 books that I've partially written.
Oh, okay. So you're gonna have a lot of unboxing videos, is what I'm hearing.
Yeah, yeah, and the Rutherford story is mostly going to go in book 3. Yeah, book 3, because
All
that's
right.
going to be about X-rays and radiation and stuff like that.
Uh,
So you might have to wait a little while for that full story.
so
And
cool.
oh well, good things come to those who wait.
Right, there you go.
Do you want? Oh, big thank you to my patrons. Make sure to check out Alexis's YouTube channel and check out my website, www.kathylovesphysics.com. Oop, it's put on the board.
Oh,
Anything else you want to add?
No, I feel like I've learned a bunch from you. I'm super excited. I'll be thinking about this as I'm working on my own geology related stories. Yeah, I'm just really grateful that you were willing to let me in on this conversation and that I got to learn from you.
Oh, well, thank you. Thank you for coming and being so nice and
Oh my
generous
gosh, my
and being a
pleasure.
guinea pig for the second podcast. Maybe eventually I'll be more organized. I never
You're just fine.
will. Okay, bye.